In this lecture, we are starting our project of building a social media photo sharing dApp with React and Truffle. Our first step is to build a new React app. So join me in your terminal or command prompt application. Here we are going to build a new React app. So for this, we're going to use npx, which allows us to access a package that we don't have installed. We're going to access create React app at latest, so the latest version of the create React app package. This will allow us to create a new React application. Let's call this our photo sharing folder. This will be the new folder that will be created, and then we're going to use npm. So we have to have npm and node installed for this to work. If you hit enter, this will create a new React app at your current location. It will install the packages that are required, which can take a couple of minutes. We are going to be installing React DOM, short for Document Object Model, and React scripts with the Create React App template. Then you get several options for testing out the new project that has been created. If you get any error messages, then read them carefully to see what went wrong, or search up your error message online. So we can already test out our app by calling cd photo sharing, which means we are entering that project folder, and then calling npm start, which is going to run the project. So this will open up your default browser, and it will go to the URL localhost at port 3000, which means this project is running locally on your computer. And you should see this template React project. Awesome, so this tells me we've been able to create a new React project. I'm going to go back into the terminal, and you can see now we have the compilation of the project has been successful, and it gives us two options for where we can see our site. We're going to use npx truffle init, or just truffle init if you have truffle installed globally. This is going to initialize a new truffle project, so we do have to have truffle installed. You should see the message starting init, copying project files to your project folder, and that the initialization is successful. We have a contracts folder which stores our Solidity smart contracts. By default, there's already one included, but you can delete it. We don't need it because we're going to create our own. We also have a migrations folder. This is where you put all of your deployment scripts for sending the smart contracts to the blockchain. Then we have a node modules folder. This contains all of the helper packages that we will use, such as the Web3.js library, Truffle, and more. Next, we have a public folder. Here we have some metadata about our React project. So some default files like the React logo, which are used to render the default React app. Then we have a source folder. This is where you have to place your front end or client code. So we are going to build out the visuals for our website here, such as in app.js. So this is where you would put all of the visuals of your site. Then we have a test folder where you can put tests for your smart contracts. We have a git ignore file, which lists all of the files to ignore when uploading to GitHub. We have a package lock.json, which is a locked version of package.json. It gets automatically generated. Package.json lists out your project metadata, such as the name of your project, the version, the dependencies, meaning what packages are being used to help the project, such as React. Some of these dependencies were automatically installed when we created a new React project. We also have a list of scripts, which means we can call npm start to use as a shorthand for a longer command. Same thing with npm build, npm test, and npm eject. We've already used npm start to use React scripts to start our React app. Then we have some extra data like linting, a browsers list, and development list, which are just more information about how the project can be run. We have a README, which was automatically generated by Create React App, giving us some information about how to get started with React applications. Finally, we have truffle-config.js. This is where you configure the Truffle project of your entire project. Remember, we have a React project with a Truffle project inside. So here you can set the networks that you're going to deploy your project to, such as a local blockchain, the test Ethereum network, or the main Ethereum network. And you can set other properties like how much gas you want to send with each of your transactions. You can define testing, and you can set your compilers. So you want to set your Solidity compiler version to 0.8.13, which is the latest version currently. So that's what we are using in this course. That way, this is the version of Solidity that will be used to compile or read your smart contracts. Then you can set even more properties here, like the database properties and more for the Truffle part of your project. Great, so we have set up our project, which means coming up next, we can build our social media smart contract. So don't miss the next lecture. In this lecture, we are continuing our project of building a social media photo sharing dApp. We're going to learn how to build a social media smart contract in Solidity. So join me in your project folder in a code editor. We recommend Visual Studio Code with the Solidity extension. This is a free extension that will provide highlighting and compilation for Solidity. So inside of your contracts folder, we're going to create a new file, and we'll call it photosharing.sol, which is the file extension for Solidity. At the top of every Solidity file, we have to pass in the license of the file, like SPDX license identifier, which is the keyword used to identify the license, such as GPL-3.0, the default, or MIT. Or other licenses, like if you want to copyright the file, or if you want to leave it open source, or if you want to require citing. There are different types of copyright licenses. So we're going to leave ours at MIT. Next up, we are going to specify the version of Solidity that is used for this contract. This is also required for every Solidity contract. We use the keyword pragma to specify that we are going to here define the Solidity version of the file. So we use pragma followed by Solidity. Then we can pass in either a version directly, like 0.8.13, or we can specify a minimum by adding a cap here. So this means that we must have a minimum of 0.8.13. Another option is to use a range, like greater than or equal to 0.7.0, but less than 0.9.0. So here you can pass in the version of Solidity that you are going to write your file in. We recommend copying exactly what we are doing. And also you must make sure that the range is within the compatibility for your Solidity compiler defined in Truffle config. So if your Truffle config lists the compiler of 0.8.13, then your files must fall within that acceptable range. Then we're going to define a contract with the contract keyword. We're going to call our contract photo sharing. Typically, per convention, you will name the contract the same name as the file. Then we use curly brackets to open the contract body. So here we have a smart contract created, but let's put in some fields as well as some functions. So one function that we need is to upload an image. We need a function to allow our users to upload images. This will require our users to send in a string in memory, which we can call the image hash, as well as a string in memory that we can call the description. Because when our users want to upload an image, they are going to send in the hash or a location of where the image exists, so we can actually render that image, as well as the description. We can also make this function public, so it can be accessible or viewed outside of this contract. Next, we want to make sure that the image actually exists. So we're going to use the require keyword to require that the bytes of the image hash are greater than 0. if there's 0 bytes in the image hash, it means that there is no image. So that's why we require that there are enough bytes. You might get a warning that the function state mutability can be restricted to pure, in which case you can add that on. But likely you'll have to change that later. You might also get another warning about unused function parameters. That's just because we're still working on this function. We also want to require that the image description exists. So we're going to require that the description bytes, so the string converted to the bytes, that its length is also greater than 0. Otherwise, that means there's no description. We also want to make sure that the person who uploaded their wallet is actually valid. So we're going to require another requirement that the message.sender, which means the sender of the transaction, whoever called the function, is not equal to address 0, which means that it is a valid address. Here we are using a message.sender. So you might get a message now that you have to restrict your function to view instead of pure. All right, so when we upload a new image, we have to make all these checks. Then we're going to increase our image count, our count of how many images we have in the contract. So I'm going to create an unsigned integer that is public called image count, and initially we can set it to 0. We can set it to 0 directly when the variable is created, or we can set it in the constructor. Then when we upload an image, we want to take image count and increase it by 1. We also want to add the image to our contract and to all of our stored images. So I'm going to create a mapping where we map a uint to an image type. So let's define this mapping, and we'll make this public and call it images. For this to work though, we have to define a struct called image to define the structure of each image. Each image will have an ID, as well as the hash to locate the image. As well, each image will have a description, and each image will have an address payable of the uploader who uploaded that image to our contract. So remove any extra spaces that the compiler doesn't want. Then we have image count, and we're increasing it by 1. The function now has to be undefined because we're accessing a state variable. All right, so here we have our contract now. After we increase the image count, we want to take all of our images, so that images mapping, and at the current image count, we want to instantiate a new image with the struct, and we're going to pass in all the required fields for the image, starting with the ID, which will be the image count, followed by the hash, which is going to be the image hash, followed by the description, which is the description argument, and followed by the uploader, which is going to be a payable version of message.sender, payable meaning they can send and receive funds. We can also trigger an event that the image was created. So I'm going to define an event called image created and define the properties of the event. Each of these events will have an ID, as well as a hash, as well as a description and an address, very similar to the regular image itself, the address payable of the uploader. Just make sure you spell hash correctly here. So we have the ID, the hash, the description, and the uploader. Just make sure you don't have any semicolons inside of your image created event because it's an event type. So then we can emit the event when the actual image is uploaded. We can emit the image created event. Our ID is the image count. The hash is the image hash argument. The description is the description argument. And the uploader is a payable version of message.sender. So here we have upload image. So this will allow us to upload an image by whatever wallet, so any wallet can upload an image to the contract. Awesome. So now we have our contract created and there's no error messages by the Solidity extension, which is reading my Solidity code. So our next step is going to be to deploy this smart contract. We have to compile it and then we can deploy it to the blockchain. So join me coming up in the next lecture where we will continue our project.